Well, hello everybody. Good afternoon. My name is Martin Kern and welcome to my session on API services for web and devices. This is one of a series of sessions we're doing this week where we're covering a whole range of technology around ASP.NET and Azure websites. On Monday, my colleague Martin Beebe and I talked about kind of an introductory session on ASP.NET, Visual Studio and Azure. Yesterday, Martin covered modern front ends where he looked at things like Bootstrap and some of the JavaScript frameworks that are available in detail. So today we're covering API, specifically Web API. Tomorrow and Friday we have more webinars. So tomorrow we'll be looking at SignalR with Martin Beebe, and finally on Friday I'll be covering running and maintaining sites in the real world. So that's all about Azure. Publishing your site to Azure. So you can still register for these webinars now. If you've come along to the ones on Monday and Tuesday, it's good to see that you're back. You obviously liked it. Thank you very much. And if you're new to it, then you can register for the ones for the rest of the week. We also have an in-person event in Reading on Friday next week, so Friday the 19th, which you can see details of on my blog. So if you search for Martin Kern, you'll find my blog there and registered for that. So without any further ado, I shall get on with the content. So we're going to broadly cover three topics in today's session. Firstly, we're going to be looking at REST API. So why do you bother with an API? What is an API? Why is it an important thing to consider? What are the advantages to use it? And then some background information on REST, some of the principles around REST. It seems there's a fair bit of confusion out there in terms of what REST actually is and isn't. So we'll hopefully cover some of that. We'll then look specifically at Web API. So this is the .NET implementation, if you like, of REST services. So when you're writing an API in .NET, you're writing a Web API effectively. We're currently on version 2 of that technology. And then finally, we'll look at consuming an API in various client devices. So we'll look at consuming APIs in web applications through the browser. We'll look at consuming the same API in an Excel app. And then we'll also look at doing the same thing in the Windows app as well. So just to show that you can use these APIs in lots of different places, we'll be covering all of that off as well. So why would you build an API? So in today's scenario, you would often find this kind of a picture where you've got several applications, several websites, and sorry, I've just realized the picture's not showing on live. Sorry about that, but don't worry, you haven't missed anything. So hopefully you can see a picture now with showing your apps without an API. So yeah, you would have several applications. So you might have apps on iOS, you might have apps on Android, Windows apps potentially as well. You might have several web applications, and all of these apps and web apps have their own pieces of business logic. So you've got code running on all of these different platforms, potentially in different languages, quite possibly in different languages. You might have one backend database. But the point here is you've got code all over the place here. So your application, the logic of your application is dispersed in lots of places. And the problem with that is when you need to make a change, so the idea guy shows up with a great idea of some new functionality that he wants to deliver. There's always new ideas, so a web application is never done. You're always working on progress. And whenever you have these new ideas, you need to change your application in lots of different places. So what tends to happen is that you have to change all of these different places. So you have to go through all of your apps, your iOS, your Android, your Windows, your web applications, your back-end website logic, and change everything. So not only is this time consuming and expensive, but it's kind of what quite often happens is you end up losing feature parity. So you end up with different levels of functionality on the different devices and different platforms. So it's not a good scenario really, and it's a scenario that a lot of people are in right now. So quite often they'll have started out with maybe a web application and then added an iOS app later on, and the things have organically grown and they've got all these different pieces of functionality all over the place. So really that's the kind of problem an API is there to address. So the idea is that all of your apps, your kind of modern applications, as well as your web applications, all talk to one API. So they have one place to go to get the business logic and the data. And the API is the thing where you put all of your hard work. So that's the thing that interacts with your database and sends data to and from the client applications. It means the apps can be very lightweight. Really, they're just front ends at that point, and you can adapt the front ends very easily and quickly to suit the requirements of the particular platform. So, on a Windows application, you may well have a very different design to what you might see on an iOS application, as an example. And having an API that they both use allows you to keep the business logic separate and be more flexible with the front end itself. So that's the happy API place we're trying to get to. So with that in mind, what's REST? So REST is a pattern. So it's not a technology as such. It's actually a way of doing things, and it stands for representational state transfer. And it's an architectural style and pattern which is basically built on HTTP. And it uses HTTP in the very essence of what HTTP is designed to do, which is transferring data to and from different places across the internet. So we use standard HTTP verbs. We use URIs as you would do in HTTP, or resources as they're sometimes called. And REST is really built on top of that standard HTTP. One of the main benefits of that is if a device can call HTTP, which any internet connected device can, then that can potentially call an API as well, or a REST API. So it's become a very popular pattern. We have other ways of doing these things in the past with web services and various other techniques, which require lots of specific implementation knowledge. The great thing about REST is if you understand HTTP, then it should be very clear as to how REST works. So again, it's not a specific technology, it's a pattern that's used, and in the case of Web API, that's just our implementation of REST in .NET. So just to give you an example of this, we start off with a toaster and an API. So the reason why we've chosen a toaster there is just to illustrate that actually, if you can call HTTP, then you can use APIs. Now, not every toaster can call HTTP. Normally, they're restricted to the toasting of baked goods. But yeah, we have seen things like fridges with CPUs on them. We've seen the various kitchen devices that are actually online now. The Internet of Things is very much alive and well. So we are seeing more and more devices that aren't traditional screens. So they're not necessarily PCs, laptops, tablets, phones. They're other types of devices. For example, in-car entertainment systems, that kind of thing. So my car has a SIM card. It can go and get tweets, which is quite dangerous when you're driving down the M5, but there we go. So anyway, so we have a toaster and we have an API. And the way it works is the toaster sends a request to the API over HTTP. So it goes to a particular URI, in this case, /API/products, sometimes called a resource. And it uses a HTTP verb to tell the API what it wants to do. So in this case, it's sending a get verb. So that means it wants to get information. And then finally, we optionally add what's called an accept header, where we say, I'd quite like this to come back in JSON format, please. So certainly, Web API in .NET has the ability to return in almost any format. By default, it supports JSON and XML. If there's no accept header specified, it will return JSON. But it's just good practice to include that anyway. So this request goes over to the API, and then in response back, it sends back a status code. So again, standard HTTP codes. We'll talk about this a little bit later, but 200 means OK. And then we'll attach the JSON with that as well. So that's just an example of the JSON. So the workflow is that the toaster makes a request to a specific URL with a specific verb and optional accept headers. The API then responds back with a status code and the attachment of the actual data that's been requested. So you can see in this particular case, it's come back as JSON format there. So in order to understand this, you really need to understand some of the core principles of HTTP. So firstly, we have resources. So these are effectively URIs or places to go. So you might, for example, have products, which you might expect to get a list of products back from. You might have products /87, where you might expect to get a product of ID 87. You may also have customers, you may have orders. So any kind of entity or type of sort of data type, you would generally represent as a URI or as a resource, and we'll look at how Web API specifically implements that in a little bit. You then have the HTTP verbs, so you can look on the W3 website to see the sort of formal specification of these verbs. Generally speaking, we only really use get, put, post, and delete. So get is where you want to retrieve data, so you want to get details of a product or a list of products. Put is where you want to update data, so you want to pass in a product that's been modified in some way, perhaps the price or the stock has been modified. A post is where you want to basically create a new item, so again with products you would post a set of data to the API and that would in turn create a new product in the database. And delete, as you'd expect, might delete a product. But then we do have all these other verbs as well, so it's important to kind of understand these verbs and really understand what they're used for and what's the most appropriate one to do. You can get into some bad practice with this stuff where you end up doing everything as a GET request and then implement logic on the client side to interpret that. It's really not the way to do it. You should really try and stick as close as you can to the HTTP standards for this. The other side to that, of course, if it's an API that's being used by lots of different organizations, so if it's kind of a public API, you need to it's even more important to make sure that you're adapting to the verbs there, because you don't necessarily know what other developers are going to do with the responses your API gives them. So finally we have the status code. So every response is sent back with a HTTP status code. And again, these are standard things. These are defined by W3, part of the HTTP protocol. And there are various formats. So you've got the sort of 200 range, which is informational responses. You've got the 300 range, which are redirects, and so on and so on. There's a large amount of these codes available. So again, I'd recommend that you go on the website there and just take a look at what the different codes are and what they do. Web API does do some interesting stuff with this in terms of it helps you send the right response code back. So you don't have to know that a 201 means created. As an example, you just send back created and it works all that out for you, which is quite handy. So the message here is really be familiar with HTTP, understand the verbs, understand the status codes. And if you know both of those things, you're in a good place to implement a good REST architecture. Okay, so that aside, so that's a bit about REST, a bit about APIs in general. So why you would use an API, what's REST, what are some of the foundations for REST. And now let's look at Web API specifically. So this is the ASP.NET implementation of the REST sort of pattern. So you don't have to use Web API to develop REST. You can sort of break the rules if you want to, but by default it's kind of set up to do those kinds of that kind of pattern. And so Web API is basically, it uses the REST architectural model. It allows you to call from anywhere or anything that understands HTTP. It can return either XML or JSON by default. It returns JSON if you don't specify, but you can have it return other types as well if you want to. That's just a bit of extra development work for you to implement that. Now the cool thing about Web API is it's part of the ASP.NET family. So it means you can mix and match this with other technology. And one of the key benefits there is you can use things like Entity Framework, identity management, so that all of the kind of core ASP.NET features that are available to MVC and web forms and all the other things, if you're at the talk on Monday, you'll sort of understand what we're talking about there. Those are all available to ASP.NET as well. So one of the ones that's used the most is Entity Framework, because an API generally is responsible for interacting with a database in some way, and Entity Framework's a really easy way to do that. So you'll see an example in a moment whereby we're using Entity Framework to actually create objects in a database without actually doing any SQL or any kind of really caring about a database. One of the other great things that we get from using ASP.NET is that when you create a Web API project, you get some automated help documentation. So the standard template includes a whole load of, it basically includes an MVC project as well, whereby it can look at your API controllers and actually construct help documentation based on the verbs and the parameters that you want in and out of those actions. So you really don't have to worry too much about documentation. If you've structured your models correctly, the documentation will complete itself, and that's one of the really key benefits of using Web API with ASP.NET. So in terms of how it maps onto MVC, so the Web API really adopts an MVC kind of model. Resources or URLs are generally represented by controllers. So in the example we saw earlier on, we might have a products controller, we might have a customers controller, we might have a orders controller. So each entity generally would be represented by its own controller. Within those controllers you have a set of actions, just like you do with MVC, and those actions generally map onto the various verbs. So a product controller might implement get through the get action, it might implement put through the put action. We'll see an example of this in a minute. And finally, the actions will respond using the HTTP response verbs as well. So, sorry, response code. So you'll say respond OK, and it will convert that to a 200 OK response automatically for you. So again, you don't need to necessarily know all of the different responses. So what we've tried to do is show the whole of an API project in one screen here. So I'm going to zoom in on the various bits, but this is a screenshot of Visual Studio. I know this you won't be able to see the detail here because it's on the webcast, but all of the bits that make up an API are showing on this screen. So when you get the slides to this later, you can kind of look at this and really dive in. So I'm just going to explore some of the key areas here as we go through. So you'll see on the right-hand side, we've basically got a project structure, and we have controllers like we would do with MVC. By default, we get something called a values controller, which is really just a sample controller to use. And if I just zoom in on that just very quickly, see some of the details there. So you'll see as we look through this that the values controller automatically implements the various HTTP verbs. So we have a get action, which just returns values, a get action which takes a parameter of ID, which returns a specific value. We have post, put, delete, and all of the other HTTP verbs can be implemented there. You don't have to implement all of them. You can pick and choose the ones that you want to implement. So if delete doesn't make sense, you don't have to implement that. So if we just look at in a bit more detail, so the standard get will return an array of strings with value 1 and value 2. So very simple default example here, just to get the idea. If we look at the put and delete verbs, the put will accept an ID and it will accept a value of string. So that's going to take the ID of the item you're updating and then take the value that you've passed in as well. And again, delete takes an ID, so it will use that ID to delete the item. So in this particular case, none of the business logic is implemented, but when we look at a demo later on, we'll see how if you choose the entity framework option with actions, then it will actually do a load of boilerplate code to implement this stuff for you. So the next aspect to this is around the routing. So Web API uses the standard MVC routing model, and what this basically means is we have a default API route such that anything, so that you have the site route / API and then the controller and the ID. So what this means is that you have whatever the site's called / API, and that goes to the API. What this lets us do is it lets us mix and match this with other technologies. So you can have other parts of the site which just use standard MVC or web forms or any of the other ASP.NET technologies. So the point here is that the routings, it uses standard .NET routing to map this stuff out. And then finally, on the right-hand side here, we have basically an MVC project embedded into here. And this is what gives us all of the help pages as well. So you'll see this in a bit more detail shortly. But we have a very clever MVC project which examines the controllers, looks at the inputs and outputs, and actually constructs help on the fly. And that's the code that does that for you. So you can dive in there and you can start having a look at that and see how that works. So that's kind of an MVC project in a nutshell. So the next thing to consider is, well, how does this fit into the wider ASP.NET family? So ASP.NET is a very broad set of technology now. It started out many years ago with just web forms and web pages, and we now have MVC. We have various other technologies, and these are the topics that we're talking about all across this week. So Web API is built on top of the ASP.NET core, and it's really around returning data to computers rather than to humans via a browser. So if a computer or a device of some kind wants to request data, they can use the Web API, but it's built on top of the same ASP.NET core that everything else is built on top of. It's not some special technology that's kind of a side project or anything like that. So time for a demo. So what we're going to show in this demo is basically the process of creating a brand new API. So we're going to go File, New Project. We're going to create the standard Web API project, and you'll see how that works in the various clients.
Okay, so we go to File and then New Project. From the menu we're going to choose ASP.NET Web Application, click OK. And then we choose what type of application we want, in this case Web API, so that's going to include Web API and MVC for us. So Visual Studio is going to go ahead now, create the default project. It's going to download any dependencies from NuGet, such as MVC and various other things there. Takes a little while to do. So then we get the documentation page. This is actually worth a look, so we get some really good links here relevant to the type of project you've created. So here it's lots of API information, so take a look at that page. The default structure contains a controller called values controller. So this is just an example controller really where we can get various values, post values, put. It has all of the basic CRUD operations in there. And then you see the root here is going to be API/values. And if we go into the config here, we can have a look at the standard root setup, where this basically means anything that is under the API will come to this API controller. Okay, so if we actually run this project now, because it's got MVC built in, it's going to actually give us a very nice documentation interface. So it'll examine the controllers, look at all of the code and work out exactly what the parameters are for each one. So if we click on API, we're going to see all of the various actions that are available here. So this is the values controller we just created, and this gives us examples of what type of inputs and outputs we will expect to see on this controller. So we look at the get specific value, and it'll see it's expecting an ID as a parameter there. And then of course the same with post. It gives you an example of what to post. So in more complex types, this will give you a full breakdown of all of the properties that we're expecting to see here. So let's go ahead and build our own controller, and we start here with building a model. So we just create a standard C# class. We're going to call this person class with capital P, and then we're just going to make this a very simple class by adding an ID property of type integer and just a string of first name as well. So very simple. Obviously in the real world this will be much more complicated, but just to get the idea. You see how we type in prop here to sort of quickly create the properties. It's a good keyword to use in Visual Studio. Just type in prop and then tab and then sort of choose from the options that are available there. So we've got the model. We can now build the project, and we're going to use the scaffolding to actually build out a new API controller. So we right click on controllers, add new scaffolded item, and then we use Web API controller with actions using Entity Framework. So the Entity Framework is the bit that's going to give us the database interaction. So we choose our model from the list here. So we're looking for the person model that we just created. It's in there somewhere. There we go. And then we add the data context class. So this is basically the database where Entity Framework is going to store all of the data as it's added. Normally you'd just keep the controller name as the default, so that's what we've done in this case. So that's created us a new controller there. So we've got the person context, which is the Entity Framework interaction, and again we've got all of the CRUD operations that you'd expect to see there, the get, put, post and delete. So it's written most of the code for us here, and actually we'll have a fully operational database driven API straight away here. If we then go into the views, we'll see that there's no views created because this is just an API controller. There's no UI for this specifically. So we go ahead and run this. As before, it's going to examine the code and actually create documentation for us. So if we click on API now, we should see there's a people section. Yep, there it is. And it's looked at all of the actions that are available and actually created the documentation for us. And it tells us what a person is, what the kind of response we expect to get both in JSON and in XML. So very good. Same there for the get of a specific type. And also if we look at post, it's the same kind of thing. It gives us the parameters that we want to post, examples that we can literally just copy and paste into a tool such as Fiddler. So Fiddler is a great tool for testing APIs with. It does lots of other things as well, most of which I don't understand, but it's great for APIs. So we just put in the URL, we grab the URL to the specific action there, choose the verb, which is get in this, or post in this case. So what we're going to actually do here is create a new person object in the database. We need to set things like the content type, so we need to say that this is going to be, we're going to pass JSON into this request, and then we go back to the documentation, copy the sample that it gives us, paste that back into the request body in Fiddler, just remove the ID and set something sensible to the name. Martin seems like a good option in this case. And then we just execute that request. If you watch on the left hand side, that's going to go away, it's going to our API now, and that's returned the 201. So that means it's been created. If we look at the JSON that's returned, it's actually returned the object in JSON back to us because we sent it in JSON initially. So that's all works very well. We can take the same request and just modify it to add another person. So let's add Bob in this case. Execute the request again. Again, that's another 201 back. And let's add somebody else as well. Let's add Billy as well. I don't know who these people are, but they seem like good names. So we've got 3 201s there. So that's basically created 3 items in the database for us. So let's take a look at what those items are. So we're going to do a GET request on the same URL. So it's still the same controller. We're just doing a different verb here. We don't need a request body for GET requests. And we execute that. So that's going to give us 200. And then it's actually returned the JSON of all 3 of those items that we just created. So notice there's no XML there because we haven't requested XML. It returns JSON by default. If we want XML, we add an accept header saying that we're only accepting application XML, and then we execute the same request, and it's going to give us 200 again, but this time it's returned XML back rather than JSON because that's what we asked for from the API. And you see we've got the full XML there in the raw.
Okay, so that was a quick demo of creating a new API. So we use Entity Framework to do the database interaction. We saw how we could use Fiddler as well to actually test the API. There's lots of other tools available. So there's a tool called Postman that's a Chrome add-in. I have a Windows app in the store called Requesty, which does a similar kind of thing. So plenty of ways to test that. So in the next stage of the demo, we're going to look at creating a more complex API using based on the GeekQuiz application. So I'll explain a little bit about how that works as we go through.
So we're going to do a series of demos now, and we're going to use something called the GeekQuiz website to support these demos. So this is a very simple kind of demo website. The basic idea that it's a quiz. So it's a quiz around geeky technology, geeky topics and technologies. So things like when was .NET first released, and the idea is that you have a series of questions in the database, each of which have multiple choices for answers, and you basically get and post the questions and answers as you go through. So just explain a little bit about how GeekQuiz works. So there is a version of the GeekQuiz application available online. It's at geekquiz.azurewebsites.net. It's a public domain. Anybody can go in and access the site and start using it. I'm going to log in with my account that I've got pre-created. And so we're just going to go through, basically the way it works is it asks a question, what do we think? I think 2001 maybe? No, wrong. So it basically what's happening there, it's calling into the API, assessing whether the question's right and telling me, give me an answer, and then it's getting the next question for me. I'm going to just guess at some of these until I get one right. What's the first and oldest domain name? No, I'm not very good at this kind of thing. Which is actually a thing, no idea. So anyway, you get the idea. So it's basically a set of questions with multiple choice answers, and that's how GeekQuiz works basically. So you've just seen a little bit about the GeekQuiz web application. In this next demo we're going to look at how we actually build the API behind that. So we can use the web API system to kind of create the GeekQuiz API, and then we're going to go on to call that through various clients, through standard websites, through an Excel app, and also through a Windows app as well. Okay, so we're going to start off and we're going to add a trivia controller to our project here. We start by just creating a new controller, and we'll just choose an empty web API controller, so this won't use any of the scaffolding that we've seen previously. I'm just going to call this the trivia controller, and I'm going to this implements the API controller class. I'm just going to copy and paste some code that I've already got saved here, just for purposes of time. And then I'm going to just line up all of the references. So you just right click resolve dependencies if you get these little red lines. It's quite a neat little trick there if you've not seen that. So this uses a couple of services. So what we've done here is separated the logic out to a separate service layer. So we've got a question service and an answer service. So the question service gets questions out of the database based on the user's ID. So it's questions that they've not seen before. And it returns that back to the calling code, and then the answer service does a similar kind of thing. It basically stores an answer, so when the user submits an answer, it stores the answer based on their ID and returns back whether it's correct or not. Okay, so that's the basic structure of the API. We're also going to add an authorization token here. So this basically means that users can't access this API unless they're authorized. If they're not logged on, it will actually redirect them to a logon page to implement that. So we're just going to now implement the get function. So this is the function that's called when we want to get a trivia question. This is asynchronous, so we just need to resolve the threading namespace there. So it's going to take the name, it's going to get a user service to get a trivia question. If it's not null, it's going to return the trivia question back to the calling code. And then we're going to implement the post action here. So this is what happens when the user submits an answer. So they submit an answer in, it checks if it's a valid model, checks if the answer is correct, and if it is correct, it returns the right status code. If it's not, if it's a bad request, it returns a bad request. So that's the basic structure of the implementation there. If we now execute this, we're going to load up the main the Geek Quiz website in IE, and we're going to just run through the code here so we can see the actual requests coming in and out of the API controller. So first, because we added the authorization token, we need to log in here. So I've already got an account set up on this particular demo, but you could register your account if you didn't have that. So it's going to load. So we're doing a get request here into the API. It's going to go into the service and pick out the first question for us. So it's using my identity for questions that I've already seen. So this is 2002, correct? And so now let's debug to see what's actually happening here. So if we put a breakpoint on both the get and the post actions, and actually post this answer here. So we're going to do a get. It gets my name, and then it uses the question service to get the trivia question back. So we can see that's coming back as a full kind of .NET object here. I can see the options and the title of the question, and then it's just returning that back. So that's going to make it into JSON object and display on the web page. So a post, it's posting the answer in. So again, I've got the identity. I'm using that to find out whether the answer is correct or not. It's not in this particular case, and again I'm returning that back, and the API is actually converting that into JSON for us. So we're doing another get request, and the process goes on. So that's how we can see how the process goes backwards and forwards. So that's the basic API there. So we've built the basic Geek Quiz API, and we've seen how that we can call that in a standard website. Now the next thing on the list is to see how we can call that in an Excel app. So Office apps are basically our websites. So the way Office apps work is they are mini websites using whichever stack you want. We're going to use MVC in this particular case, but it could be PHP or just any web technology you want. And they use JavaScript to basically interact with Office through an Office JavaScript library and to do whatever else they need to do. So in this case, what we're going to do is we're going to have an Excel app which calls our API, gets some statistic information from that API, and displays that on the Excel worksheet. Okay, so in this project we have an MVC API controller which gives us statistics from the Geek Quiz database. Don't worry too much about exactly how this works. It's just know it's an API controller. It's going to return JSON with a bunch of statistics inside it using the standard web API framework. So because this is an Office app, we have an Office app controller. Office apps are basically web applications, and that standard MVC web application. So it returns a view called index, And in that view, we have several things. We have basically a button which, when clicked, will call that API control and update statistics. The click event for this button is handled in JavaScript inside the Office app.js file. So all Office apps basically use JavaScript to interact with things. And it's just standard kind of JavaScript stuff here really. We just handle the click event for the button. We call something called update statistics table, and that uses the getJSON function to call out API. So basically it's going to get ask for JSON from the API. So if we run this now, it's going to run as an Excel app. The interface you'll see on the right hand side is basically the MVC web application, and it's kind of shown as an iframe within Excel. Because we're running both the web app and the normal app side by side, it's actually going to load the web app as well separately, so we don't want that, get rid of that. So we do update statistics, and it's going to give us the initial view, so that's called that API. Notice we've got 6 correct and 9 incorrect answers. So if we go into the site itself and just give some answers here, mostly incorrect probably if I'm answering them. I'm not really a geek, don't tell anybody. So we just go through and just put some quick answers in here. I'm doing quite well on the incorrect here. Surely I'm going to get one of these right sooner or later. Nope. Nope. That's got to be 115, surely. Nope. We wrote the first computer program. Nope. Not doing very well at all here. Okay, so we've answered almost 100% incorrect there. And a quick update of the data, and we see that that's instantly updated the Excel app from the API. Okay, so in that last demo we saw that we could use an Excel app and we could call into the statistics API and use the data there in Excel. Next on the list is calling the API from a Windows application. So we have a HTML JavaScript version of the GeekWiz app, so it's basically a Windows app. You can write Windows apps in either HTML, JavaScript, or you can choose C# and XAML, but because we're a web developer gang, we're going to choose the web technology here. So what this app's going to do is it's basically going to mimic what the website's doing already. So it's going to call the API, get a list of questions, and then it's going to post answers and get new questions. We're going to use the WinJS XHR function to call into the API, and you'll see how it's basically the same API under the hood, and we're just doing a different client app to call it. Okay, so first we've got a trivia controller here, just like we've had several times today. That's just a standard web API, and then we have a HTML Windows app which contains a view model which calls that API, and then basically uses WinJS.XHR, which is the way you call APIs in Windows apps, to get the JSON out of the API. It then passes that into an object, and then we use that object to bind to the view model. So if you've done Windows apps before, this is fairly familiar to you. If you haven't, don't worry. We have a view model.js, and then we basically bind that to the various elements, the buttons on the screen, and that's how we get the data to and fro. So to test this, we're going to run the API project first, because obviously the API needs to be there in order to call. That's just going to spin up in IE because it is a web project. We just get past these breakpoints here. And then secondary to that, we're going to call the Windows app project. So we'll just go to Solution Explorer and just debug that separately. Okay, so that's basically going to call into the API, get a list of questions, we can post that back. It works in exactly the same way as all the apps that you've seen so far today in terms of the process. So let's look under the hood here and find out what's actually going on in the API here. So as I said before, the API is exactly the same as we've seen several times. It has a get and a post, which does a trivia question and trivia answer. If we post an answer to that, it will convert the JSON to an answer object, and it goes through using the answer service like we've seen before. And we do next question, and then it does a get, and it works exactly the same way.
Okay, so that's the end of the main demo. So what we saw there is several things. We saw the creation of an API around the GeekWiz platform. We called that using a browser, an Excel app, and also a Windows app as well. And the reason why we did that is just to show the point that you can call this using any technology. So it doesn't. It can be anything that calls HTTP. Like I said before, a toaster could call that API if necessary. And so that's the end of the main content. So just to summarise what we've covered. So we talked about why you would build an API, what are the benefits of actually having an API type architecture. We looked at REST and some of the principles behind REST and the kind of whole HTTP model. We then looked at Web API specifically. So Web API is just a .NET implementation of the REST architecture. We looked at the sort of the anatomy of a Web API. We created a few very simple APIs using Entity Framework, and then we looked at a more advanced one using the GeekWiz platform, and then we consumed that in Excel and in Windows apps. So I hope that was useful. I know a few people had some audio issues there. I'm very sorry about that. We will make these videos available online somewhere. So if you follow me on Twitter, I'm at Martin Kern, or if you follow my colleague Martin Beebe, who is at the Beebs, we'll make sure that we post the videos and the content somewhere where you can download that and watch it offline if necessary. So anyway, so this is day 3 of the week of webinars. So tomorrow, Martin Beebe will be covering real-time communication with SignalR. So this is a really amazing technology for doing real-time communications between client and servers across a very broad range of clients as well. So very interesting stuff, well worth a watch there. And then on Friday, I will be covering running and maintaining sites in the real world. So this is all about Azure. It's about publishing your site to Azure, debugging in Azure, how to kind of scale your Azure instances up and down using the auto scale and all of that kind of stuff. So you can still register for these webinars. The URL is aka.ms/Azure Websites Training. And we've also got the in-person event on Friday the 19th as well. So if you look on my blog, you'll be able to see details of that. So I hope that was a useful session for you. Please follow me on Twitter, have a look at my blog, or if you've got any questions that we didn't answer during the course of the presentation, then you can send them to me at martin.kern@microsoft.com. Okay, thank you very much.
So, Martin, the few questions in there. Someone asked to retweet. Michael's asked you to tell him what your Twitter profile is again.
Sure. Okay, it's at Martin Kern. So you can tweet me on there. Please do.
It's on your front slide there. If we push that to the audience, should be able to see it in the bottom left-hand corner. Oh no, it's not. Yeah. You removed it.
So I'll push another slide which will show that. So yeah, it's at Martin Kern. Okay. And then you can, my blog is blogs.msgen.com/martinkern, and you can email me at martin.kern@microsoft.com. So lots of ways to get in touch. I'm very responsive, so please do. So were there any other questions that we had during the course of the presentation that didn't get answered, Martin, or is that, are we covered? Sounds like we're covered. Okay, great. So thanks very much. I hope that was useful, and I hope to see you in one of our other webinars soon.
XML. Is it still worth keeping support for XML when building new APIs? It absolutely is. Some systems require XML support. The reason why JSON is more popular is because you can express the same amount of data in fewer bytes. So mobile applications obviously want to pass as little content over the wire, and just because of the way that the brackets work in JSON versus the way that the fact that XML is slightly more verbose, you can send less data down the wire.
Okay. Do we have any other unanswered questions?
I found API help products, Papery, Swagger, Raml, 3Scale, but does MS have any such assets or assists? But I think it needs assets. Well, it's interesting you say that. Some of that stuff isn't in the Web API, but there is a new service which just got added, which is called the API Manager, and that's in Azure. And I believe that has that sort of stuff built in. I've certainly heard, I'm not familiar enough with some of those technologies, but I know that Swagger, or there's some level of Swagger support or something in that new API management. tool in Azure, which is a tool for fronting these APIs. So rather than, you can actually take any API which is out on the web, even an XML-based API, you can front it with the Azure API Manager and convert it on the fly to JSON. But also that creates documentation for the API as well for you automatically, and even allows you to bill and sell the API and basically manage the API. So there is a service that we provide called API Manager, which may or may not be what you're looking for there.
So just a few other questions that have come in. So there's a question about how Web API can be secured. So this is one of the great things about it being based on ASP.NET. We can use the standard authorized tokens that you see on ASP.NET. So you may not have seen that, but basically you can, for any action or controller, you can just put authorize, and that will make sure that it passes it down to the ASP.NET identity subsystem. So it's exactly the same way you would in MVC or any of the other ASP.NET technology. So yeah, very clear, very straightforward to do. There was a question around... Go on, Martin,
mentioning with that, I recently wrote an API which required a different set of authorization. It just required like a single token auth. And so obviously it's ASP.NET, those filters are extensible. So I just wrote a new authorization filter for my web API, and then handled authorization using my own sort of third-party hacky way of doing it. But it's just a point that you can use the ASP.NET authentication, or you can just write your own filter for authentication and put that onto and apply that to the web API.
Okay, and then one other question was just about what's the URL to register for the other webinars. So hopefully you can see that on screen now. If you want to register and come and see us in person next Friday, the 19th, I think it's aka.ms/christmascamp. You can go on either of our Twitter profiles or my blog to see the details of that if you wanted to come along and see. A lot of the content's the same, but sometimes you get a bit more detail in person, and we can go sort of off the script a little bit more as well. So come along to that if you can. I'm just going to do one last refresh to see if there's any other questions that we need to address. Okay, I think we've covered everything there. So if we've missed you out, if you've got a question that we haven't covered, please just email us and we'll get onto that for you. I'm going to close the call now. So thank you very much, everybody. I hope that was useful. I'll see you soon.